On June 8, 2021, at 9:50 UTC, major platforms like Reddit and Amazon simultaneously vanished behind a 503 service unavailable error. In an instant, 85% of the provider's global network went dark, severing connections for millions of users across every continent. The early internet, rooted in the ARPANET project, was engineered for extreme resilience. It was theoretically designed to route around destroyed nodes, even in the event of a nuclear strike. This infrastructure, built to survive the ultimate physical devastation, was brought to a global standstill by a single line of bad code. To find the root of this modern fragility, we have to look past the cloud. 97% of all internet traffic travels through physical subsea cables. Repairing this network is a massive industrial undertaking. When a line is severed, specialized ships and icebreakers must navigate extreme environments to pull the cables from the ocean floor. Despite these logistics, the hardware layer is highly redundant. Individual cable cuts are common, but traffic simply shifts to other physical paths, rarely causing a global disruption. These paths terminate in massive data centers, the physical endpoints of the modern web. While the hardware layer is built to withstand extreme physical challenges, the modern web is increasingly susceptible to the invisible logic of the digital fast lanes built on top of it. Traffic navigates these fast lanes using the Border Gateway Protocol, or BGP. It serves as the Internet's mapping system, using autonomous system numbers to chart paths across different networks. To make routing decisions in real time, routers must store the entire global map in high-speed hardware memory. This process still relies on legacy 1980s architecture to handle current traffic. This legacy architecture hit a critical limit on August 12, 2014, an event now known as 512K Day. On that morning, the global routing table unexpectedly grew to more than 512,000 entries. Many older routers had a fixed memory capacity of exactly 512,000 routes. When the table crossed that threshold, the equipment ran out of memory and instantly crashed. BGP configuration errors continue to cause modern blackouts, such as the 2021 Facebook outage, where a bad command effectively disconnected the company's servers from the world. Trusting a decades-old mapping protocol to manage the exponential growth of the web creates a structural weakness where a localized routing error can have global consequences. Another digital choke point is the Domain Name System, or DNS. This is the directory that translates human-readable URLs into machine IP addresses. On October 21, 2016, a cyber attack targeted Dyn, a major DNS provider. The disruption made major sites across North America and Europe unreachable for hours. The attack was executed through the Mirai botnet, which infected mundane devices like baby monitors and printers. Millions of these compromised devices were triggered to launch coordinated lookup requests, overwhelming the central DNS provider with a flood of data. Centralizing address translation into a few massive providers makes the web efficient, but it also creates a single point of failure that can be weaponized by hackers. Content delivery networks, or CDNs, add another layer of efficiency. They cache content on edge servers, accelerating delivery to users and reducing strain on the internet backbone. The June 2021 Fastly outage was caused by a latent software bug introduced during a routine update weeks earlier. In these highly optimized systems, a single routine input can trigger a widening cascade of failures. A single customer making a standard configuration change unknowingly triggered the dormant bug, crashing Fastly servers globally. Systems designed to prevent network congestion accidentally cut off 85% of their own traffic. While Fastly resolved the bug within an hour, individual websites survived the outage differently based on how their networks were built. Reddit went offline completely. Relying solely on Fastly created an immediate dead end. The New York Times minimized downtime by manually rerouting traffic to Google Cloud servers. Amazon and eBay stayed online using a multi-CDN strategy, automatically shifting volume away from the broken path. This seamless transition is managed by automated load balancing, detecting failing paths and redirecting traffic in real time. Architectural diversity, not relying on one robust provider, is the most effective way to survive a structural collapse. The internet faces a paradox. The centralization required to make the web fast has inadvertently created massive single points of failure. Future resilience depends on automated safeguards, such as staggered software deployments and commit-confirm rollbacks that can stop a bug before it spreads. The internet cannot be taken offline for maintenance. It must be rebuilt and repaired while continuously processing the world's data traffic. As the network continues to grow, the engineering mandate has shifted. The goal is no longer to prevent every failure, but to ensure the network can route around the damage as quickly as it occurs.